Hello there, and I'm going to teach you how to rationalize the denominator. Rationalizing the denominator is where you have a surd as a denominator, and you need to convert that surd into a rational number. If you want to know what surds are, refer back to my previous video on how to simplify surds. You can get an idea of what a surd is. So when rationalizing the denominator, this has to be done because it is bad practice in the mathematical world to leave the denominator as a surd. So you have to rationalize it, make it into a rational number. There are rules that need to be applied when you're rationalizing the denominator. For example, here with the first rule, when you're encountering a rationalizing denominator where the fraction is in the form of a over the square root of b, you have to do a over the square root of b multiplied by the square root of b over the square root of b. And you'll see why. You'll see why when you multiply square root by square root, that cancels out. Because I'll show you the meaning of indices and how you when you multiply square root by square root, it just cancels out. So I'll show you that. Here's the second rule: a over b plus square root of c. So this is when the denominator has another term in the denominator other than just a surd as a denominator. It might have 1 plus the square root of 2. With that rule, you have to multiply by the conjugate of the denominator. Conjugate means changing the sign between the two terms, so it's the opposite. So for example here, for this rule, we do a over b plus square root of c, and you multiply it by b minus the square root of c over b minus the square root of c. This is because of the binomial a squared minus b squared, which I will go into later on in the video. So let's tackle the first question. Rationalize the denominator. 1 over square root of 2. So let's write that out. 1 over the square root of 2. We refer to our rules. So when a term is in the form of a over the square root of b, what do? We do a over the square root of b multiply the square root of b over the square root of b. Okay, so we're going to do 1 over the square root of 2 multiplied by the square root of 2 over the square root of 2. You'll see why. So we end up with 1 over square root of 2 is equal to, so what's 1 multiplied by square root of 2? Square root of 2. What is the square root of 2 multiplied by the square root of 2? 2. And there's your answer. That is the denominator being rationalized as, because now the denominator is no longer a surd. It's no longer square root of 2. It's just 2. So this is what we mean when we say rationalize the denominator. So if you didn't understand why when you multiply a square root by another square root, that cancels out, it's because a square root is the same as writing the term to the power of a half. So for example, the square root of 2 is the same as writing square root of 2 to the power of a half. So then in that case, if we're going to be multiplying square root of 2 by square root of 2 is equal to 2. So in it as here, square root of 2 multiplied by square root of 2 is the same as writing 2 to the power of 1.5 multiplied by 2 to the power of 1.5. So when you multiply those two together, by the laws of indices, so that's what's going on when you're adding the indices. Therefore, you've got 2. A half plus a half is 1. So therefore, you've got 2 to the power of 1, which is the same as 2. So yeah, that explains why you have 2 as a denominator when you multiply the square root of 2 by the square root of 2. So let's move on to the next question. Rationalize the denominator 2 over the root of 3. This is the same process as we did with the first question. So 2, if you remember, a over the square root of b multiplied by the square root of b over the square root of b. So we're going to write as 2 over the square root of 3 What's 2 multiplied by the square root of 3? 2 root 3. Write in fraction form. 2 root 3. And as I demonstrated in previous question, when you multiply square root by another square root, it cancels out. So the square root of 3 multiplied by square root of 3 is 3. And that is 2 over the root of 3 rationalized with the denominator rationalized. So yeah, 2 over the root of 3 over the 2 root 3 over the root of 3. Rationalize this denominator. Same process, except for this time, the numerator has a third in it also. Equal to 2 root 3 over the square root of 3 multiplied by root 3 over root 3. So now we do the same process. So luckily with the first two questions, you know what happens when you multiply a square root by a square root. The same square root cancels it out. So when you multiply 2 root 3 multiplied by the square root of root 3. So now all we have is 2 multiplied by 3, which is 6. Because 2 multiplied by 3, because the square root, remember, if you remember from the first two questions, when you multiply the power of indices, so the same as writing the question as a half when you with a square root. So that means 2 multiplied by 3 is 6 divided by 3. 6 divided by 3 is 2. So yeah, in the end, you did rationalize the denominator, you can just write as 2, and that's the denominator rationalized. And the final question, rationalize the denominator 1 over 3 plus the root of 5. So here we're going to apply our second rule, as I explained at the beginning of the video. We're going to apply this rule here. So 1 plus 3, 1 over the 3 plus root 5 is equal to 1 plus 3 plus the root of 5 multiplied. We're going to multiply the conjugate. So 3 minus root 5, 3 minus root 5. So we multiply the conjugate because if we did, let's say 1 over 3 plus root 5, I'll show you what would happen. So let's write it. So if we decide to do it like this process, you would still end up with a third at the denominator. That's why, because multiplied by 3 plus the root of 5, you're gonna get 3 plus the root of 5. Root of 5, and 3 plus the root of 5 multiplied by 3 plus the root of 5. So you multiply one term by all the other terms in the other equation. So one term from another equation, so you're going to multiply 3 multiplied by 3, which is 9. Then you're going to do 3 multiplied by root 5, which will be 3 root 5. Then you're going to multiply the second term by everything in the equation. So root 5 multiplied by root 5 multiplied by 3 is again 3 root 5. You're probably seeing why, because when you collect the like terms, you're still going to have a third as a denominator. And you're going to do root 5 multiplied by root 5, which is 5. So then when you collect the like terms, you'd end up with, you'd still have a third as a denominator. So that would defeat the purpose of rationalizing the denominator if you multiply this way. This explains why we multiply by the conjugate instead. So let's carry this out. 3 minus root 5 3, going to multiply this 3 by everything in this equation. So 3 multiplied by 3 is 9. 3 multiplied by minus root 5 minus 3 root 5. Now we're going to multiply the second term in the equation by everything in the other equation. So root 5 multiplied by 3, that's positive. You've probably seen already now why we multiply by the conjugate, because in the end the thirds are going to cancel out. And root 5 multiplied by minus root 5 is just minus 5. So as you can see, the thirds cancel each other out. Minus root 5 plus 3 plus positive 3 root 5. They cancel each other, it becomes 0. So now you have 3 minus root 5 over 9 minus 5, because these two cancel out, becoming 0, is equal to 3 minus root 5 over 4. And there's your answer. And that's how you rationalize the denominator when the denominator doesn't have a singular third. It might have a term added onto the third. So that's how you rationalize the denominator. Thank you for listening, and goodbye.